Let's take a look at section 6.7, which has sum to product formulas, and since we're all feeling very generous today, we might go ahead and take a look at some product to sum formulas as well. So those are right here on the sheet, product to sum formulas here, and for some reason, with this weird gap in between, the sum to product identities are at the very bottom, so people tend to miss them for some reason. But both of these derive from the sum and difference identities. You can see that if we took these two equations and we subtracted them, then we would solve for sine A, sine B, and the other parts would cancel out just like this. Pardon my poor notation here, but writing that all on one line just takes up entirely too much space for my preference in this video. It's not super exciting, but it does work out. How about an example? We want to find the exact value of sine of 195 degrees times sine of 135 degrees. Doing that is pretty easy. We're going to use the formula we just had here, where A is 195 and B is 135. Who would have guessed that those work out to numbers that we already know the cosine of exactly? It is truly amazing. You can check that with a calculator or with Wolfram Alpha or something like that, and it will show you that that does in fact work out. You can use these formulas even when you don't have numbers, you just have symbols like this. They don't have to be A's and B's exactly. In this one, A is 9 theta, B is 2 theta. So go ahead and look at the formula for sine times cosine, which is this one. Put in your values for A and B. You get 1/2 sine 7 theta plus sine 11 theta. That may not seem very useful, but this gets a lot of use, I believe, in electrical engineering and anything where you're dealing with waveforms. But I don't know for sure. In this class, that doesn't seem a lot simpler to me, but that's what you're supposed to do, so just go with it. This is a sum. Let's turn that into a product. To do that, just go down to this formula here. We have cosine of something plus cosine of something. That is going to be this formula. Here A is 3 theta, B is 5 theta. Like so. But on the last step, don't forget that the cosine of negative theta is the same as the cosine of theta, because cosine is an even function. All the problems just work out like that. Just make sure you know what A and B are, put them in the formula correctly, simplify, and that'll be that.